We're going to solve the system of equations that you're given by matrices. Now notice I've already written down the coefficients of the x's, the coefficients of the y's, and the constants, and this is a matrix. It's simply an array of numbers. So let's go ahead now and solve. Remember, to solve, we want ones along the main diagonal and zeros below the main diagonal. So I'll start by making sure this is a 1, which it is, and now I'll concentrate on making this a 0. To make this a 0, I'll multiply this by -3, and I'll add it to this element. So -3 times this element plus this element, and I'll do that throughout. Here's -3 times this plus this. Do the same thing, -3 times this plus this, and then -3 times this plus this. And let's go ahead and simplify. Row 1 has not been changed at all. Row 1 is still 1, -1, -2, and we have -3 plus 3 is 0 like we want. This is 3 minus 3, it just happens to be 0. And this is 6 minus 6, that just happens to be 0. Now if I go back and write this as a system of equations, look what I've got. I've got x minus y is equal to -2, and here I've got 0x plus 0y is equal to 0, or I have 0 is equal to 0, a true statement. Remember what that means? It means these are dependent equations, their graphs are the same, and there's an infinite number of solutions. How can we write down the solutions? Well, we can write the set of all ordered pairs x, y, such that I'll just use this equation, but you could use the second equation of the system if you'd like. X minus y is equal to -2.